Welcome back to another Python tutorial. Today I'd like to start off with a joke. Billy and Bob are walking down the street and Billy says to Bob, "You see that fine thing over there?" And Bob says to Billy, "I don't see women as objects. I consider them to be a class of their own." That one always cracks me up. But anyways, if you don't understand that joke, I hope you will understand that by the end of the video. Today, we're going to be going over an important skill called object-oriented programming. And this is a huge skill in all programming languages. So let's start up that code editor, and get learning. So classes are the heart of object-oriented programming. And instead of creating new variables with information stored in them in the form of dictionaries, we use classes. And instead of the variables inside classes, we usually refer to them as objects, which are essentially like variables, but they have properties to them. And you'll understand what I mean once we get started. So once this code editor loads, okay, here we go. So I'm going to create a new Python file. Oh, geez, a little laggy. I wonder why. Okay. I'm going to call it OOM Part 1. OOP Part 1. Okay. So let's say we want to create a district. And inside that district there are multiple schools. Inside each school there are tons of students inside. And let's say inside the district we wanted to keep a list of all the names of all the students with all the different properties inside of them. Well, we know we could use dictionaries and lists. So essentially what we do is create a district variable and we turn that into a list. And inside that list we could organize this in different ways. We could have another list with schools, organize it by schools, and each school would have a dictionary worth of all their students with their different properties inside to the students. Or we could just have a list of all the students, and I think that's what we're going to do for the sake of simplicity. So we're going to create a new dictionary. And let's say for the first student, we're going to name him Bob. And for each of these students, we're going to give the following properties. We're going to give each student an ID. We're going to show their grades, their ranking, their class ranking, the sports they play, and the school they attend. So, as far as grades go, we'll do grades. Let's do ID first, because that makes the most sense. Let's say Bob's ID is 1, 2, 3, 4, 5, 6. Say his grades. Say he's not the brightest of kids, and we're going to create a list to hold all the grades. Let's say he usually gets his grades in following classes are 99, 77, 65, and 67. And let's say he's a pretty athletic kid, and he plays. We're going to create another list again to hold the sports he plays. So he plays soccer, football, golf, and basketball. Yeah. And the student goes to Western High School. As you can see, it didn't take me very long to make just one student. But let's say this district has millions, or not, okay, millions might be an exaggeration, but thousands of students inside the district coming from different schools. doing this for each individual student could get a bit tedious, and it's very inefficient. This is just one student. What happens when we want to add multiple students to our code? You can tell this would take a very, very long time, and it would be very messy if you wanted to store them into if you wanted to add more students to the list. We'd have to use the append function and append a new student like this. So let's say we wanted to do district, we'd have to use append, and inside that append function we'd have to create another list like that, and you can tell that would be very, very long. That would take a very, very long time, and it'd be kind of tedious for each individual student. Okay, so I mean, we could store each dictionary into separate lists, and I guess that would organize it a bit better, but in the end it doesn't save us from the real problem of inefficiency and creating all these long dictionaries. Instead of doing this, there are other ways of storing information neatly, and that's where classes come into play. You can think of classes as functions that have a lot more features to them. Although they may look similar to functions, they're very different and they can't be used in place of them. Classes and functions are very similar in nature, in the way we make them. Instead of using the def keyword, we use a keyword called class, and that's how we make our classes. So, of course, we have class. Then we have the name of our class, and then we just do that. And that's how we would create our class. You would notice that in functions, we use the def keyword with the name of the function with parentheses and then the colon to say that whatever the action is. You can tell the differences here are one uses def, one uses class, and that's how we differentiate functions from classes. Classes generally are named with using an uppercase letter, while functions use lowercase letters, just because it's just generally the right thing to do when you're coding in Python. It's not mandatory, but it generally is just the right thing to do. If you notice that in functions we have parentheses to hold our parameters, but in the class we don't have any parentheses. And this is the reason why we don't have any parentheses is that if we are not trying to, let's say, sync this class to another class, we don't use parentheses. So if we wanted to basically call upon another class within our class, that's when we'd use these parentheses in this case. Okay, so I'm going to show you a better way of creating this district. Okay, so every class has a Dunder method, and Dunder methods are basically built-in functions inside the class, and they're kind of like how Python has built-in functions like range and print and input, as we talked about in previous videos, but classes have their own built-in functions, and those are what we refer to as Dunder methods. And the reason why we call them Dunder methods is because we use double underscore to signify them. So they're just like any other function in the sense that you use the def keyword and they have parentheses and then we call the action. This special Dunder method is the Anit method, and almost always you will have this Dunder method inside classes when you're making your classes. This is usually the first thing you create when you're making a class, and basically what it does, it initializes all the variables that you want the class to have for you to use them later on in your code. So we're actually going to do this. We're going to create a student class actually. And you'll see right here inside the init method that we have this parameter called self. And self is what we refer to as the object. It initializes all the variables for that object. So if we wanted to add properties to it, we would type out self, which is referring to the object inside the student, which is the student, and we do dot, and let's say we want to create the ID, and we would set it equal to whatever we want it to do. As you can see, this ID is now a property of the object student. So what we're actually going to do is that we're going to create more parameters inside this Dunder function. We're going to put the ID. We're going to do, well, first of all, we need the name of the student. We're going to need their ID. We're going to need their grades. And we're going to use, say, sports they're in and their school. Okay. So I'm gonna set this up. So what I did was I created a class called student, and inside the student method, I have this Dunder method, the init, and essentially whenever I try to create a new student, I need to pass in these variables before it can create that student. So the self refers to the object, which is the student, of course. I have the name of the student. You need the student school ID, grades, sports, and the school they go to. So over here, as you can see, I did self.name equals name, self.id equals school ID, and so on and so on. So what this means is that I created properties for the objects, and those properties are equal. For each of those properties, I assigned the each one of these parameters. So we can even try this out. So I'm going to create a new student, and the student's going to be Bob. And the way we create a new student we call the student class, and inside student we need to pass in a couple things, a couple arguments. So Bob's name is going to be Bob, of course. School ID is going to be 1, 2, 3, 4, 5, 6. No, that's a period, not a comma. Say his grades are like the ones previous, 99, 77, 65, and 67. Sports he plays, just copy and paste the ones we made previously. And school, he goes to his Western High School. Okay, now if we print Bob, the variable Bob, I see, you'll notice something a little interesting happens. So let's go and run our code. You see that it didn't actually give us what we thought it would give us. We thought it would give us all those properties, but it just gave us this weird thing called _main _student object at some weird numbers and letters. So Bob is an object that we created from our student class. Basically what this means is that it's saying that Bob is an object of the class student. So if we had multiple classes, this is a great way of trying to figure out what class Bob is associated with. But if we wanted to call one of the following properties from Bob, we would just do Bob, and we use dot. Let's say we want to find his name. You'll find out it prints out Bob's name just like that. And this makes creating new students a lot easier than it was before. Another useful thing classes can do is that we can store functions inside of them. So, for example, let's say if we wanted to change the school of a student. Let's say they change schools. Change school. So we create we'll create a function called change school, and inside that function we'll pass the parameter self, and which means that we're going to be changing one of the object's properties. Inside that function, we're also going to call another parameter school, or we'll name it new school. If only I could type. Okay, so what we're going to do is we're going to say self.school is equal to school. And you'll see what happens when we call that function. So say let's print out Bob's school first, and after that we're going to call the function. The way we do that is we first type out the object that we're obviously wanting to call the function for, and inside for that object we'll call the function, which is change school, and let's say he goes to Eastern High School. And if we print out Bob's school again, we'll see that it has changed. See, it went from Western High School to Eastern High School because we called the function change school to change one of the object's properties. So as you can see, classes are way more efficient when it comes to storing information than using lists and dictionaries. The classes offer a lot more functions, and they're just a lot easier to read when we're going through our code. Thank you for coming to the end of the video. Leave a like, subscribe, and if you have any questions, don't forget to just comment down below. Thank you.